We're here at Skate 1, home of Bones bearings, Powell-Peralta, Bones wheels, mini logo, and we're going to get a tour of the entire facility from George Powell himself. Let's do it.
Actually, this hallway is where almost all initial tests of wheels occur. It's a really smooth surface, so it's a great place to check roll. We can start down there and give them a couple of pushes and see how far we go. I've kind of got mentally calibrated for the last 30 years, man. Can check rebound. Wherever there's a knot in the tree, it's potentially an imperfection. So what we do is we sort through the veneer. It comes pre-sorted, but it's not always perfect. And there's certain rules that you sort it by to make it a face grade for the outside, which is a perfect veneer, or a core, which might have something like this in it. Doesn't affect the strength, then you don't see it, or it gets cut out. So what we do here is we resort. So we go through again and secondary sort our face grade veneers. We end up with, this happens to be a really nice burl piece, but we end up with sorted veneer that then goes through our sander, because the faces have to be sanded. This is a three-step process. It's a coarse, medium, and fine. Comes in like this, which is right off the blade, and it comes out of a 220 finish, just like baby's bottom. Really nice finish. The important thing about this particular machine is that because it's so accurate, we can size the veneer. So what we do is we measure the veneer coming in. We know what our stack width is going to be. So what you want to do is make the board as thin as you can so that it's as light as you can. But it turns out that because the strength of the board varies with the cube of the thickness cube, it's very sensitive to thickness. So we take it down to the minimum that gives us a strong board, a good bounce. And if you go like 10 thousandths farther, just 0.01 of an inch, they'll break like that. Very sensitive. So what we do is we size our outer veneers here so that the 7 plies add up to just what we want. So this gives us control, and we can make the board very consistently smooth within plus or minus 10 thousandths, which is very tight tolerance. Doesn't look like we're laminating at the moment. First thing you're going to notice when you walk in here is the smell and the temperature. And that's because we're controlling the humidity. We're trying to normalize the veneer, and it sits on our shelves stacked with air running in between it. All our veneer is from the Great Lakes area of America. It's like right around Michigan, upper Michigan. It's hard rock maple. And we normalize it here for maybe a month. So we've got a lot of veneer stacked up, normalizing, and then we pull it out and process it in decks. If you don't control the humidity really carefully, for all of your different veneers, you've got long plies and cross plies. You guys good with that? Okay. They come in on different pallets in different shipments, and you need them all to be exactly the same moisture content. Otherwise, when you put them together, they'll shrink or expand, and it'll cause the deck to tweak. So to keep it from warping, humidity control. This is kind of an interesting press. It's a bladder press that we developed here in order to press our decks using air pressure instead of hydraulic pressure. The reason is that by using a bladder, we can squeeze all of the different layers together. If you put your fingers together, you'll see there's like little cracks. And veneer's the same way, but kind of on a microscopic level. And what most people do is they squeeze really, really hard, squeeze the high spots down to the low spots so that you try to get good glue spreading out and an even layer of glue. What we do is, by using a bladder press, we don't have to have two hard halves. We have one hard half. If you look in here, you'll see this aluminum hard half. This is the mold that gives the shape to the board. It's cast and then it's machined. We precision machine it in our machine shop so that each of our molds is probably within about 1,000th of each other at any one point. This bladder we make also in our urethane shop. This is polyurethane and it's pre-formed to the shape of the board, and then we pressurize it over here, and it forces everything down onto one side so that if there's a high spot, it stays high. If there's a low spot, it conforms. So our decks are not totally flat. If you looked at them really, really closely, you'll see that there are slight variations, really slight, but you have to like hold it to the light and try to see it. But that's because we don't crush the boards. The net result of doing it this way is we press at about 90 psi. And when you're doing hydraulic press, you have to crush it. So you do 250 psi, pounds per square inch, on the hydraulic presses. That crushes the wood in places, and it gives you a good joint, but we don't like to crush the wood. So we use this press, which is unique to us. It's just so that we thought we could make a little bit better product this way. This is a stack of pressed boards. Now it has the shape of the board itself. And there's a stack of 4. And you'll notice it has a center line mark on it. And if you look closely, you can see an indentation on both ends where it was on the press. That tells us this center line. So we have 2 center lines for drilling. So we know exactly where the center of the concave is, right off the mold itself. That's critical, as you well know. The next thing you have to do is you have to put holes in the board. This is a fixture that we've had to make ourselves, a machine. There's a lot of special equipment in our plant. You can't really buy equipment to make skateboards. You have to kind of make your own using standard industrial stuff or completely invented stuff. Like our presses are completely invented and built here. Here we're using industrial components and then building a machine using those components. These drill heads are standard, but the frame and all the other mechanisms are ours. If you look underneath it, this ring determines the shape of the board. Here's a finished board that you can compare your finished product to. This is a reference board. And then the boards go onto a vacuum chuck, and they're held by pins. There's 2 pins, and a vacuum chuck sucks it down. Take a look at this shape. We're doing some new fun shapes. It's a Powell-Peralta fun shape. You can see the router, the head goes down. Now this particular machine is set up with 2 tables. So normally if you're doing a big run, you'd be setting this table up while this one's routing. And then the machine would just go over to that table and you'd pull these. When the boards come out of the router, they have a sharp edge. So the first thing to do is to radius the edge. So they're radiusing the edge on a small router setup. So we put a radius on the top edge to begin with. And the next step is to sand it. Look at the dust collection. The shop is so clean because we have amazing dust collection in this run. Really strong vacuum. You can see the dust come off of the part and go right into the dust collection. Where all the dust goes, and inside this is vacuum bags, kind of reverse vacuum bags. And they're clean on the inside and they're dirty on the outside. And they're shakers that shake them. And the dust falls down, and it moves it over to the middle, and then down to another screw, and then up into our dumpster. So the dust just comes from dual channels up into the dumpster. Stick the ink to the board.
Right.
And then this will peel off and it'll just leave the graphic. Here's one of those top transfers that you saw before being made.